Unit 15 is an intro to calculus, which sounds scary, but actually this is like the fun and the easy part of calculus. It's a little intro that's more graphs and just interpreting them and what's called finding limits. So 15.1 starts out finding one-sided limits graphically. And before even we get to limits, they want you to understand the difference between just finding a function value, which is something you've done in algebra, having something that's f of a number equaling something, and it's always going to equal just the y value. But we'll have a lot of piecewise functions, and piecewise functions are little pieces of functions put on the same graph. And so number 1 says f of -2. So you go on your graph and you find where x is -2, which I'm going to highlight this vertical line here. This is not actually a point since it's an open circle, but this is since it's closed. So f of -2 is the y value, which is -5. Number 2 has f of -1. Let me even zoom in a little bit. F of -1 you can see is also happening where there's a split on this vertical line, and both points happen to be open and open, so there's no point here that exists when x is -1, so we call that undefined. And there'll be a little undefined button on Delta Math you push. So that's all that is. Then let's talk about a limit. This notation is going to look different than anything you've seen before. Has LIM for limit as x approaches a number from the left of the function equals something. So again, it's a y value, but it's not necessarily is there a point there. It's what is the y value approaching as x is going to that number from the left. So on this one, we want to approach -1 from the left. Well, again, I'm going to highlight here where x is -1. And so I could either come from the left, which would be from this way, so it's not going to the left, it's coming from the left, which is coming from the negative x's, or from the right. So coming from the left would actually be using this piece, and so I'm following it, following it, following it. What is y approaching? 4. It doesn't matter that there's an open circle here. That's what a limit is. It's just what is it approaching. If I would have been coming from the right, I would have been following this quadratic piece and I would have been approaching +1, but that's not what they want. All right, let's try another one. Limit as x approaches 3 from the left. So find where x is 3. So it's here where the split is happening. I want to come from the left, so I'm coming from these negative x values. That would be this piece right here. Following, following, y's are getting bigger, and then this point has a y value that's approaching 2. In fact, it is 2, but we just need to know what is it approaching. All right, and then we have the right-sided limit. So it looks exactly the same. The limit as x goes to a number, but it's going to have a plus sign here. That means from the right of our function equals what? So the limit as x approaches 3. Which is again right here on a break. Now I want to come from the right, which is my positive x values. So I don't even look at this piece. I look at the one that's from the right, which is here, and I'm going up to a y value of -5. And last one, I'm approaching -1 from the right. So go to -1, come from the right, so that's this piece. It's a quadratic piece and it goes up and up and up. What does it approach? 5. Again, it does not matter that there's a hole there. It's just what are we getting close to?